Isomerism means we know that is the same molecular formula will be there, but different structural formula will be there. That is called isomerism, right? So in coordination compounds also we can see different types of isomerism. So mainly we can classify them into structural isomerism and stereo isomerism. So in case of structural isomerism, we can say that isomerism commonly same molecular formula, different physical and chemical properties or different structures will be there. So structural isomerism means difference in the properties because of the different shape or structure they have. Means these compounds have different structures and they can be again classified into ionization, then solvate, linkage, coordination. Then stereoisomerism we can divide it into geometrical isomerism and optical isomerism. Okay, so isomers are compounds with two or more atoms arranged differently at the same chemical formula. They have various physical or chemical properties because of the, like, as I said, it means they have same formula but different physical and chemical properties. Okay, so we are moving to the different types of isomerism in coordination compounds. The first one is geometrical isomerism. Geometrical isomerism are of mainly two types, cis and trans isomerism. So if you consider these complex, here you can see platinum. The complex formula is same, that is platinum surrounded by 4 ammonia and 2 chlorine. So this is the, see, both the compound have same formula, but see the structure. Here 2 chlorine atoms are neighbors, but here 2 chlorine atoms are opposite. So this is called cis and trans. If the similar groups are arranging in opposite direction, that is called trans isomer. If the similar groups are arranging in adjacent way, they are called cis isomerism. So the octahedral complexes show cis isomerism and square planar complexes can also show cis isomerism. Okay, square planar means ML4 type like this. LLPP. This is cis. Trans means LLPP. This is trans. Okay. Now, the next type of isomerism, that is optical isomerism. Optical isomerism means we can say this is related to the optical activity, means how the compounds are behaving to the sunlight, behaving to the light. Okay, that is called optical. Means optical means how the compound is behaving in presence of light. Okay, so optical isomerism, we can say that here we can see one compound. So optical isomerism means they are non-superimposable mirror images. Means if you take, this is a compound, right? So if you take this compound and taking the mirror image of the compound, means we are placing a mirror on this lactic acid molecule. So this is the mirror image of the compound. So if you take this compound and placing on the first one, see, this is the thing and this is the mirror. So I'm getting, this is the thing and this is the mirror, I'm getting this image. I'm not placing like this, I'm taking this compound. So otherwise I'm taking this is the thing and this is the mirror is here. So this is looking same. I'm not placing like this, I'm taking the image and placing over the other one. So it is not superimposing. Superimposing means this finger will be this here, but here it is an opposite. That is called non-superimposable. Okay, this is superimposable, same fingers on same, but this is non-superimposable. If you place the mirror image on the original one, you are getting non-superimposable. You are not placing like this, you are taking that one and placing over the other one. Okay, so here the mirror images are there. So optical activity, we can say that when the, polarized light and unpolarized light, right? So unpolarized light means the light particles which is vibrating in all direction. That is called unpolarized light. When an unpolarized light is passing through some polarizer, they will convert into polarized light. Polarized means they are vibrating in only in one direction. Okay, so this is unpolarized light and this is polarized light. Now, when this polarized light is passing through some chemical compound, the plane of polarization of this light can be rotated by this compound either to right direction or to left direction. Okay, see, this is the polarized light. Now this polarized light is passing through this chemical organic compound. Now the plane of polarization of this light is rotating in right direction. Here it is rotating in left direction. If the compound is rotating the plane of plane polarized light into right direction, this compound is called dextrorotatory. If the compound is rotating them into left direction, this compound is called levorotatory. Okay, this is the difference between dextro and levorotatory compounds. Okay, now here the optical isomerism means normally, as I said here, the non-superimposable mirror images are called optical isomers. So these optical isomers, the one that is if the dextro one is a substance, that is the one form is rotating the light into left direction. Other form, that is the mirror images, will rotate the light into right direction. That is called optical isomerism. Next one is linkage isomerism. So linkage isomerism means we can say here the how they bonded to the metal. See here, suppose you are taking a ligand that is NO2. NO2, that is nitro group, right? So there is a importance with this nitro group. The nitro group can link to the metal atom either through nitrogen or through oxygen. If this group is connecting to the metal through nitrogen atom, we can call it as nitrito N ligand. If so, we will write like NO2. If the nitro group is connecting to the metal through oxygen, we can call them as nitrito O group. So that will be ONO. Okay, so NO2, ONO. These are the different types of way in which the nitro group can be linked to the metal atom. So either through nitrogen atom or through oxygen atom. They cannot use both nitrogen and oxygen at a time, either through nitrogen or through oxygen. Such type of ligands are normally called ambidendate ligand, and they are forming the complex C. Another example is this one, SCN and NCS. Here, this SCN group is connected to the cobalt through sulfur. Here, these two nitrogen. No other changes here, right? So, these type of isomers are called linkage isomerism. How they link to the metal atom. That is the linkage isomerism. Okay. Next type of isomerism is coordination isomerism. So coordination isomerism means here you can see this isomerism result from the ligands of various metal ions. So here you can see a coordination isomerism means this is the complex. Here CrNH3 6 times. The second one COCN 6 times. What is the difference here? See here the first compound is one example in which the NH3 ligands are linked to CO. Here the NH3 is connected to cobalt, Cn minus is connected to chromium. In the second case, NS3 is connected to chromium and Cn is connected to cobalt. They are just changing their metal atom, or we can say they are changing their ligands. This is one complex and this is another complex. So here the difference is cobalt is changing. Cobalt and chromium is interchanging the ligands. Here again cobalt and chromium is interchanging. That type of isomerism is called coordination isomerism. Okay, so this is the other type of isomerism. Next one is ionization isomerism. Ionization isomerism means we can say here, if you take this complex CONH3 5 times SO4Br, so here we can say the things outside the bracket is called ionization sphere, right? So here the difference is, in case of this complex, I am changing the sulfate into outside and keeping the bromine inside. Means I am changing the ionization sphere into coordination sphere. So these have same formula, but here when you ionize this first compound, you will get this complex ion plus Br minus. When you ionize this one, you will get this complex ion plus SO4 2 minus. That is the ions you are getting will be different for these two complexes. These complexes are called ionization isomerism. Okay. So in case of ionization isomerism, formula is same, but the things outside the sphere is going inside and the things inside the sphere is coming outside. So if you ionize them, you are getting different types of ions. That is the difference. Okay. Now solvate isomerism. The solvate isomerism means we can say here the water is using as a solvent and other thing is similar to that of the normal solvate isomerism. See here, normal means how we are doing the ionization isomerism. See here, aqueous complex is here and the solvate isomerism is this one. Means here the water is coming outside. So see here the entire property is changing. Color of the complex is changing. Okay, so this is similar to that. This is solvate isomerism, is hydrate isomerism is because here we are using water. That is a solvent. So here this is similar to that of the ionization, but here the thing that we are interchanging is water molecule. That is the difference. Okay. Now here see how is the solvate isomers and hydrate isomers are same or different. As I said before, this is a process of surrounding the solute with solvent molecule means same thing. Okay, now see the coordination number 4. How can you identify whether the compound is tetrahedral or square planar? How can we identify the structure? If the ligands surrounding the metal atom are all identical and relatively small, the molecule is likely to adopt tetrahedral geometry. That is the difference. If the ligands are larger, they are steric or electric factors, they will take square planar geometry to minimize the repulsion. Okay, so the simple question that we can expect in your board exams. Okay.